And welcome back to SAT Math Question of the Day. Before we begin, these questions come from the SAT Educator site. These questions are on those 6 Blue Book tests. So if you haven't taken those 6 Blue Book tests, maybe you should not watch this. But this question will appear on one of your diagnostic tests. We have to do a alert for that. Okay, anyway, here is the question. How many solutions does the equation 10, open parentheses, 15x minus 9, close parentheses, equal negative 15, open parentheses, 6 minus 10x, close parentheses, have? Okay. So this is the classic question of how many solutions a linear equation has when you have an x on both sides. So you got to be careful because sometimes the weird things happen and you can have more than one answer. If you have an x only on one side, if you have an x on only one side, like 3x is 12, then you only get one answer. You just solve for x, and x is 4. But when there's an x on both sides, you have to be careful. So probably the best thing to do is distribute it. 150x minus 90 is equal to negative 15 times 6 plus 150x. And this has a calculator, so you can multiply what? What's wrong? You can then multiply this out. We have a calculator.
You're just wasting time.
I know. I know. Okay, so this is a negative 90. So you see that
Don't waste everyone's time.
Okay. Anyway, you can see that both sides are exactly the same. And if both sides are exactly the same, particularly this 150x and this 150x are exactly the same, you know that it's not going to be 1 and it's not going to be 2. It's either going to be infinitely many or 0. So it's infinitely many when these things are the same.
No. If both sides are always exactly the same,
yeah,
then every value of x gives a solution.
Right.
So if they're both exactly the same, both sides, it's immediate that they're infinitely many solutions. It's not possible that there's 0 solutions.
Right.
As soon as you said both sides are exactly the same, that implies there are infinitely many solutions.
Right. Now, What about this 6 times negative 15? How do you know 6 times negative 15 is 90? You do.
You're wasting everyone's time.
You have to multiply
Go back
6 times
and look
15.
at the numbers and find a much quicker way of simplifying it.
You mean you divide both sides by 15 or something?
No.
Somehow you have to figure out whether 6 times 15 is equal to 90 or not. Don't you? No?
Okay.
Go ahead. What's the pattern? What's the pattern you can use?
Let's do a guessing game. I'll give you a hint.
Okay.
The concept
divide by 10.
Begins with letter.
So you're saying
Which
divide
letter?
by 10. You're saying divide by 10.
F.
Factor?
F. Letter F.
Factor?
Factor. Pull out some common factors.
Wait, but that takes too long. Just multiply 6 times 15.
Wait a minute. Wait. Is it so bad to divide both sides by 5?
Yes. Yes, it is.
And then divide both sides by 3?
Yes. It's easier to take your
and then divide both sides by 2.
Look, you put 6 times 15 in the calculator, you see it's 90.
No. See, there's 10. 10 is multiplying one side. 15 is multiplying the other side. You divide by 5.
Fine. So you get
and
2,
change the 10 to a 2 and the 15 to a 3.
2. So it's 2.
Cross out the 10 and replace it by a 2.
Is equal to negative 3, 6 minus 10x. Okay, I see what you mean.
And you see that beautiful 2?
Yeah,
on the
yeah,
left.
yeah. This is 30, and this is.
And
wait,
the 6 and the 10 are both divisible by 2. So you get rid of the 2. And you see the 3 on the right, both 15 and 9 are divisible by 3.
No way. You don't. No, no. When you're here, you see 2 times 9 is 18, and 6 times
No,
3 is
no,
18.
don't multiply it out. If they're divide the whole thing by 2.
Seth, it's easier to multiply than divide.
No,
Come on. Are you kidding me? Really? You serious?
I mean it's so you see a 2 sitting there right in front of your nose. It's like here.
I don't see a 2. Where do I see a 2?
Don't you see it? So you wrote it down. There's 2
there's
times
a 2.
the quantity.
Yeah.
5x plus 9.
No, 15x
See?
minus 9.
Look.
Look, it's 15x. Wait, it's 15. What did I do? I divided by. No, it's 15x minus 9.
Yeah.
No.
Go to that. Go to the equation line, right?
Yeah.
Look at the 10.
Yeah.
Divide the 10 by 5 and get 2.
Yeah, I got 2.
And then on the other side, you see the 15. Divide the 15 by 5 and get 3.
I know, it's right here, yeah.
Yeah, now. Right? Now. You see there's a 2 on the left-hand side.
Yeah, of course.
And look on the right-hand side. There's a 6 and a 10.
Yeah?
What kind of numbers are 6 and 10? They're even
so
numbers.
You can divide by 2.
Yeah. And now there's a 3 multiplying the entire right-hand side.
Can't be.
On the left-hand side, there's a 15 and a 9.
Okay, look.
Both of those are divisible by 3.
Look, let's figure out what you're looking for. When you have a problem like this, you have to decide, are the 2 equations exactly the same, or are the 2 equations different?
Okay, that's what I'm doing. It's easiest
idea.
to see whether they're the same by simplifying. They simplify as much as you can.
No. You start with the problem. First thing you got to figure out is, are the variable terms the same? That's the big question, right? You decide, are the variable terms the same, and are the constant terms the same? That's the decision. So it's easy.
No. The decision is, are the whole.
Yeah, but you could break it into
are the
parts.
quantities on the left equal to the quantities
so you break
on the right?
it into parts
Together.
Are the variable parts the same, and are the constant parts the same?
The whole thing. Are the whole things the same?
No, but you don't have. But that slows you down. Listen to me. Check the variable terms. That's easy. 10 times 15 it's easy to multiply by 10. That's 150. They're trying to get you here with negative signs. Negative 15 times negative 10 is also 150. So that means that you can cross these out. Okay? So that's the variable terms tell you that the answer is either going to be C or D. The constant terms now decide, is it infinitely many or 0? If the constant terms are different, if the constant terms are different, then it's 0. If the constant terms are the same, then it's infinitely many. That's what you have to do. You do one type of term.
Let's just agree. Let's agree that what you're saying you have to do is not what you have to do. There are 2 different approaches.
Right. Of course. Right.
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 So a second approach, which I would find quicker, is to just simplify like crazy by throwing out obvious common factors.
So that's you.
Yeah. So we figured it out.
So in other words, we each have different ways of doing it.
Yeah.
Right.
Yeah.
The bottom line is you got to figure out, are the 2 equations identical or not identical? And you also have to really pay attention to the coefficients of the variable term. Because if they aren't the same, then you're going to get weird answers, like what I personally call weird answers are infinitely many and 0. Okay, so we agree that the 2 equations are the same, so they're infinitely many.
Yeah.
I took all the Blue Book tests. This question is on a Blue Book test. So, doesn't matter if it's on the real test. They're going to give the same question. They're just going to give different numbers. And hopefully by the time you take the Blue Book test, if you are listening to this, you will have forgotten the specific question, but you'll remember the ideas. So that's it. Oh yeah, should we do our 4 questions or 5 questions? do we calculator? Well, I personally think a calculator could be handy. 6 times -15. You have your calculator here. I would not use Desmos. Just keep a calculator next to you. Start with the guess. Well, I mean, not really. These are the answers, but starting with the guess and working backwards doesn't really work here. Does this different from a school test? Absolutely. They could easily ask this. They'll ask you to solve this. They'll ask you to actually solve this, and the answer would be all real numbers. Technically, most people say all real numbers. So why doesn't it do? Which one is better? No. If you were going to ask to solve this, exactly what would you say? Would you say all real numbers? What exactly would you say on the school test? Solve. What would you say? Uh-oh, he's thinking. This is not a good sign.
Well, it's some approaches would the school test, some school tests, some school curriculum would ask, what is the solution set to this equation?
Okay. Let's say the teacher isn't that sophisticated and simply says, solve.
I think
solve
then they might ask how many solutions,
no,
or they might say,
no.
Describe all the solutions.
No, it's just a test where it says solve for x, and there are 5 equations, and 4 of them are normal things like 3x plus 2 is 8x plus 9. Right? There are 4 of these on the test.
Yeah.
What
do they will they on a school test? Will they give you solve for x?
Yeah.
And then they give you an equation that has many solutions.
Yes, that's what I was just saying. Yes. So how would you answer that on a school test?
I don't know. I'd ask the teacher.
Oh, come on, just answer. What would you say? I mean, I think most.
I would say
all real numbers.
I would answer that the same way as describing the solution set. I would say, well, if there's only one answer, I'd tell what the answer is. If there were 2 answers, I'd say what the 2 answers are.
Right.
I would say, if it's infinitely many, I would say all real numbers are solutions.
Okay.
Or all numbers are solutions.
Yeah.
And if there are no solutions, I would say impossible. There are no solutions.
Okay. Fine. Okay. Anyway, so now patterns. Yeah, there are patterns here. Things cross out very nicely the way Seth was doing it.
And the way Joel did it too.
Yeah, there are definitely patterns. And main idea, very important. Last thing we talk about, the main idea, the really most important question. What are the test takers, the committee that made this? What were they trying to see if understand?
I'd say it's distinguishing the 3 classes of solution sets to single variable linear equations.
That's very nice. We should have to remember that for the name of the video.
One infinitely or 0.
Right. Yeah. Right. That's
0 size.
That's the key. That's
none,
the key.
1, or everybody.
Exactly, and hopefully, we went over how to do that. When the variable terms are the same, then you have to look further. It's going to be infinitely many or 0, and if the constant terms are the same, it's infinitely many. If the constant terms are different, then it's 0. Yeah. At this point, I don't know whether people would solve for x. You certainly can do that, and it's not. You can do that. You can do that. You can have 150x minus 90 is equal to minus 90 plus 150x. You want to get the x. You want to get the x's on one side, so you subtract 150x. These cancel, which means you have negative 90 equals negative 90. This is true. So then there are infinitely many solutions. So you could certainly do that if you want. Okay, so should we see how they do it? So we clear all drawings, and we see the big reveal. Okay, good. It's a short explanation. Applying the distributive property to each side yields this. Applying the commutative property of addition to the right-hand side yields this. Okay, not quite necessary. Okay, since the two sides equation are equivalent, the equation is true for any value of x. Therefore, the given equation has infinitely many solutions. So that's pretty direct and reasonable.
I would say are the same.
Okay. Okay.
Why? Because otherwise it's circular reasoning. It's circular reasoning. Because the equation is true. The equation is true for any value of x means the two sides are equivalent.
Okay. Oh, I see what you mean.
Equivalent. Yeah. And they say here, the two sides are equivalent. So it's circular. The equation is equivalent. The two sides are equivalent. Then the two sides are equivalent. But what's important is that the two sides are equivalent. One of the possible ways you're going to have two sides that are equivalent is when two sides are the same. That means equal.
Right.
Right?
Right.
So an example of two sides that are equivalent but not equal
but no matter what
is
you're above
3x.
You're above the line, right lower.
3x plus
right
2.
Lower. Seth, right lower. You're above the line.
Okay, here we are. Not the same. Not the same.
Yep.
But equivalent is, let's say, for 3x plus 2 is one side, and the other side is 6x plus multiplied by
plus
4.
Plus 4.
So these are, they're not the same. They are not the same. These two sides are not the same, but they are equivalent. Okay? And when they're equivalent, it means that whenever you plug in an x on one side, you get the same value on the other side.
They're not, how are they equivalent?
When they are equivalent means that they plug in x one side, you get the other side.
Well,
and that means when they're equivalent, then there are infinitely many solutions. But one way, the simplest way to know that they're equivalent is that they are the same.
Right. Yeah.
All right.
Right. Okay.
So in algebra, the way you test whether two sides of an equation are equivalent is you how would you do that? You do simplifications. One way is to do simplifications that preserve equivalence, such as multiplying or dividing by the same non-zero number, or adding and subtracting of the same number.
Yeah.
And or actually to tell if two sides are equivalent. Let's see if both to simplify while preserving equivalence. You take each side and divide it by the same thing, and then when eventually. No. They're equivalent let's see. How do you show that these two sides are equivalents? How do you show that they're equivalents? Well, actually, are they equivalents? Are they not? They're not equivalent, right?
No, 3x plus 2 and 6x
They're not
plus 4 are not
equivalent.
equivalent.
But they're the hmm.
They are equivalent. They don't even graph the same line. 3x plus 2 has a slope of 3 and has a y-intercept of 2. 6x plus 4 has a Now you're getting confused. You're confusing yourself.
Yeah. So, these are the same.
So let me ask you another question, though. Why do teachers in middle school and lower high school, why do they always say all real numbers as opposed to just all numbers? Is that because they just haven't taught complex numbers yet? I mean, why do you have to say all real numbers?
Yeah.
But it's true for a complex number, too, right? It'd be all complex numbers.
I was going off. I really went down the rabbit hole with that one.
I hope people.
So okay, everyone erase that. It's embarrassing. That's a big boo-boo.
We're not going to erase it. It's embarrassing. Part of math is humiliation.
Yeah. These two sides are not equivalent. Absolutely not.
Yeah, that's what I was wondering. When you were talking, I was saying those sides don't seem to be equivalent. You said if you put an X on one side, you get X on the other. I said, no, you don't. But anyway, we all make mistakes. Math is humiliating. Okay, so you don't really have to say all real numbers in a problem like this. Can't you just say all numbers? You don't have to limit this to all real numbers if you were going to say all numbers, right? Why do you don't have to restrict it to all real numbers. Okay, just want to be sure. Okay, so before we embarrass ourselves even more, part of math is making mistakes and understanding them. So I hope everybody watched the whole video, because if they stopped here, they would take away Seth's PhD in math, which he has, and I have a PhD in mechanical engineering.
Yeah, I guess so. I should come and take it away.
You should take it away, right? Because then we have a permanent record on the internet, on the cloud. I'm Joel. We already said what I've got, and Seth. We are here we're brothers. We try to meet every day to go over one SAT math question. As you can see today, we definitely had different approaches. We have different backgrounds with different people, even though we're blood relatives. And we're here to offer different approaches on how to approach the SAT, with some emphasis on what is the main idea, what's the most important idea in every problem, because that's the key to the problems. Get that main idea right, and you're well on your way to solving it. Practice on all the Blue Book tests, all 6. The rumor is that Blue Book 4 and 6 are the hardest and closest to the actual digital SAT. So pay attention to those tests. And whatever section, whatever questions whatever, if there are any topics you're weak on, go to Khan Academy. College Board partners with them, and they have tons of questions on each topic that you could perfect your skills on, and try to get yourself as many practice questions as you can. And learn from your mistakes, which we make a lot of. Okay, I guess that's it for today. Please dislike our video. Please leave comments. We take our comments very seriously. And if you have any SAT math questions from any source, or practice questions from any source, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them online here. Okay, everyone, have a great day.